Hello, 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 Kevin here, and welcome back to the second episode of Kerbal Space Programming. Woo! When we last left off, we had just been able to research flight control, which gives us access to this really cool scriptable control system. If we take a look, okay, it's not going to stay up. It's going to stay, no, okay. Well, if we take a look at it, it does require electric charge, but this is what we are going to be using for most of this series to automate our ships, which is going to be super cool. And as it says, would you trust life and limb to a mindless autopilot powered by untested software you hastily wrote yourself? Of course we would. So we're going to go ahead and demonstrate how that works real quick. And before I do that, I'm going to really quickly upgrade the vehicle assembly building, because this is going to give us basic action groups and also support a much higher number of parts, which is going to be great. So let's go ahead and do that now. That's going to cost a bunch of our funds, but I think it's worth it. Okay, so Kerbal OS is the mod that actually gives us this part that we just unlocked, which is under command control, the scriptable control system. And now we can get this info. So it says it's a kOS processor. It's got a maximum disk capacity, which means that we can't write scripts of too large of a size. So let's go ahead and throw that on here just to give a bit of a demonstration. And let's throw this here. We'll go ahead and add some landing legs on. This is just kind of to demonstrate what this is able to do. And let's put a parachute on top, for safety. Alrighty, so here we are on the launch pad. Let's get rid of this and zoom in a little bit. And I can right-click the scriptable control system and click open up a terminal. And now we get this little computery environment. And the really cool thing about this mod is it really does simulate a full programming language and environment within Kerbal Space Programming. You also see it's taking a lot of power to do that, but we've got some power in the command module, so we should be okay. Let's go ahead and try running a really simple command, print, and I'll open quotes, hello world. And all of the commands written in Kerbal script have to end in a period. So I'll go ahead and hit enter, and there we go. It said a thing. So that's cool. We know that it works, at least. Let's try something more complex. We'll go toggle gears. Oops, toggle gear. There we go. Okay, and see, it turned it off, but it was already on by default. That's weird. Let's go ahead and turn this. There we go. And now look, our landing legs have deployed, and we're still kind of sinking because this is a really rough launch pad thus far. Now, of course, we can't really sit here and type these things in real time because humans are not fast enough to just, do that. And even then, that would be kind of the same thing as letting Kerbal do stuff. We're just, doing it with longer text rather than hitting keys. So let's try and do something a bit more interesting. We'll go edit first. And this is actually going to let us open up a file where we can write some cool stuff. And I'm going to go print retracting legs. I'll end that with a period. And then I'll say toggle gear and print launching parachute, deploying parachute. That's better, right? And we'll hit stage. So stage is actually going to fire this event. So we'll go ahead and save that and exit that. And now we can go here. We saved that onto our local system. And if we type list, it'll give us a list of all of the files that we've saved. And this one is 78 large, and we've got some free space remaining. So we can write some longer, more complex programs. But let's go ahead and run this. Boom. And it deployed our parachute, which didn't do much, and it retracted the landing legs. So that is kind of the basics, but we can do more complex stuff. So let's go ahead and write an actual program. Okay, so I've got a very simple ship here. We're going to call this Scientology #1. And the goal of this ship is not really to go to space, not really to do much of anything, but to let us get some additional science. Because if we're going to power this scriptable control system, we're certainly going to need batteries. The other thing is that without a command module, that is without these command pods or a probe body, we can't actually run any of these scriptable things. So we're going to want to unlock the probe body as well. But what we want to do is take some science from the launch pad, then shoot this up and let it tilt over a little bit until we get into a new area, and we'll go ahead and reset the experiments and take more science. Now, the Kerbals, there are multiple different kinds. One is a pilot. We're not going to be using those. But we can use Bob Kerman, who is a scientist, and this means that he can actually go ahead and reset these experiments. So let's go ahead and look at writing a program that can actually drive this. It should be pretty simple because we're only dealing with kind of 2 stages, but we would like to automate this because Bob is not really one for flying. Alright, so I have a file open here in my text editor of choice that you could do this in Notepad or in Sublime Text or really any text editor. You could do it in Word if you really felt like it. The gist is that we can actually save this file within the Kerbal installation root directory. There's a directory called ships script. And then we can go ahead and save this file to, let's go ahead and call it science.kS. Yes, KS. So we go ahead and save this file, and then we can go ahead and actually load that up from within the game. And we can actually copy it onto the ship and then go ahead and run it. So we can actually write all of these scripts ahead of time and not have to worry about doing them on the launch pad. So what we want to do is start off by saying, running program. We'll go ahead and do that print command that we said before. And remember, every line has to end with a period. These up here, by the way, I put these in. These are called comments. Comments in here start with 2 slashes, and basically it means that they are not going to be executed. So if we were to try and do something like stage in here, it's not going to run. This is useful for us to kind of make notes about what we're doing. So what we're going to want to do first is lock the throttle to 1.0. Now the throttle is, the engine, and we're going to go ahead and set it to 1.0. So we're going to set it to full throttle. This ranges from 0 to 1. Now lock is an interesting thing. It's something that you don't see in a lot of programming languages. In certain languages like say JavaScript, you'd say something like var throttle equals 5 or something like that. And what that's going to do is going to say, okay, I have a variable. This is a value that I can get later, and I could say throttle +1 and do various things with that. What lock does is it actually says whenever anybody asks about what this throttle value should be, you need to return this value. So it's going to go ahead and constantly recheck it to make sure that it's the same. So we've locked the throttle to 1, and the way that we set up the ship, it's going to tilt over automatically. So we can just go ahead and say print. Actually, nope, we're going to actually have to stage. So we'll go ahead and type stage. And that's kind of our first set. That should get our rocket in the air. And then what we want to do is to wait for a reasonable period of time. Let's go ahead and make it 10 seconds. And there's a command to do that. We'll say wait 10. In other languages, you may see things like sleep, sleep 5. And this is going to say, wait for 5 seconds and before running whatever you put down over here. More stuff. Okay. So we'll go ahead and wait 10. And then we have our parachute in the next stage. So let's go ahead and type stage again. Although, we could say print, deploying parachute. And then we'll go ahead and stage. And that is all that we need to do for our program. At that point, the program can terminate, and we will hopefully not die. So I'll go ahead and save that as science.ks, and we'll go ahead and run it. Okay, so here we are on the launch pad, and we've got Bob Kerman ready to go. And before we actually launch the program, let's go ahead and do some quick science, because we want to get as much as possible out of here while we can, so that we can unlock that probe body and get some batteries going. So we'll go ahead and observe all this stuff and save that. Can we do a crew report? I'm not sure. Nope, that's not worth much. Okay, so now what we have to do is let Bob hop out. And okay, good, he didn't fall. Let's try and do an EVA report. Okay, nothing there. What we can actually do is collect the data here, and it'll say, warning, the data can't use the module if you do that, and restoring the functionality will require a scientist. But we are a scientist, so we can go ahead and click restore. And now, just like that, we can go ahead and take another copy of the experiment later. So we'll go ahead and do the same thing with this Science Junior here. Go ahead and grab the data, and okay, come on. There we go, restore. I'm nervous he's gonna fall off. That ladder's looking iffy. Okay, so we'll go ahead and hop in. We'll go ahead and board. And now we're ready to go ahead and launch up our program that we just wrote. So let's open a terminal. And one cool thing you can do here is we can say list volumes. So by default, it's gonna list the files on the current volume. That is the thing we're running now. But if we hit list volumes, we can see it actually shows us 2. There's the current one, and it's got the asterisk there, so that's us, number 1. And then there's number 0, which is archive, which is that directory that we just put our stuff in. So I'm going to say switch to archive, and there we go. Okay, so, and then I'll go ahead and say list files. And now we see inside volume archive, and there are a couple of files that I had written to kind of test out some stuff, but we see our science.ks, and free space remaining is infinite because there's no cap on what we're able to throw in the archive. So we'll go ahead and switch to 1 because that was the name of the volume we were currently on. I'll go ahead and say copy science.ks from, we can either say archive or we can say 0. So I'm going to say 0. And now we should be good to go. Let's go ahead and type run science. And you can do the .ks or just leave it off. It'll know what you mean. So I'm just going to say run science, and then we'll go ahead and grab some experiment data while we are in the air. Okay. There we go. Oh, you know what? This isn't operable. This is okay. I can't do... Okay, it's not going to let me do that. That's fine. But the program ran. See, we're running the program. We deployed the parachutes. And now let's see if we can... Oh, that's why, because I was stuck in the terminal. Let's go ahead and grab that science quickly before we land. And observe the mystery goo. All right, well, that's not much, but it is something. Right, can we do a crew report from here? Let's see. Nope, okay. Now, the one thing is that this is a rather tall vessel, so I actually put these parachutes, these radial mount parachutes, a little off-center, so this thing will land... not kind of top first, because we need Bob to be able to get out and get to all these experiments and get on the ground and all that stuff. But the program has ended now, so there's nothing more that we're going to get out of here. Unfortunately, I believe it's still drawing significantly on our power, but we can go ahead and close that up now. And we'll just jump ahead, do some time warping as we land here. And we're getting close. Don't die, please, and don't disturb the instruments. Alrighty, and safe without breaking anything. Good. Okay, so can we do a crew report now? Is that gonna do? Okay, that's something from KSC, from Kerbal Space Center. Let's go ahead and save that. So we are in a new biome now, which means different science. It's different from being on the launch pad. So let's go ahead and hop out. Let's see if we can do an EVA from here. Nope, it says we're flying over the shores. All right, fine. Let's go ahead and collect the data from the mystery goo. Let's see, and restore that. And collect the data from the Science Junior. Good, and restore that. And hop back in. Grab some more science. We're being really greedy, but we want that probe core and those batteries so we can do more cool stuff. Alrighty, and let's hop out one last time and see if we can get something from the ground itself. And let's do an EVA report. Alrighty, well, that's a little bit. That should give us something. Let's see, can we hop back in? I'm not sure. Iffy. Okay, there we go. Boarding, and let's recover and see how we did. Alright, 51 science. That should be just enough. And we got some funds from the recovered parts. That's good. Let's go ahead and take a look and see. We needed, I think, 45, so we are good. We can get the Stay Put Nick and these batteries and a thermometer, which will be nice for getting some additional science. Okay, so now that we have our probe and batteries, there is a contract that I've had my eye on. Now we have a maximum of 2 active contracts, and we already have one that is Orbit Kerbin, but I played around with actually trying to do that on this run, but I figured it was just going to be a little too complex to try and code up while we're just getting started. So what I want to try and do is take this contract to test the LV909 Terrier liquid fuel engine. Now this is a very fuel efficient engine, but it's not super great on land. It's much more suited to space. One of the challenging things with this contract, though, is that they've got all these conditions. So they want us to kind of test this, and we have to be over Kerbin, we have to be flying. And here's the tricky part. We have to be going 400 meters per second between 3,000 meters and 9,000 meters up. So that's going to be tricky, but I think we can pull it off. But it's very important that we actually have the probe now, because I'm not sure that we want to risk a Kerbal to this mission. So we'll go ahead and accept that. And I have gone ahead and built us a ship that should be capable here. Now this is going to be iffy because we need to rely on these solid fuel boosters to get us up to speed as fast as possible so that we can fire off this engine while we're going very fast. Hopefully this should get us, I've called it Orbiter 1, but really this is a suborbital trip. We've got a thermometer on here so we can get some science as we go. There's also, and it's unfortunately a little hidden here, but there is a, I'll just go ahead and throw that off and put that back on. There's a reflectron, which is, this is part of the remote tech mod, and what this does is it lets us stay in contact with the ship so that we can actually transmit the science down as we're going, because otherwise we would be out of contact. This thing would be fully automated and unable to deliver any of our science. So I'll go ahead and remove that. Now all we have to worry about is actually writing a script to do this. What we want to do is fire everything as fast as we can without spinning out. We've got some winglets on here, but it's still kind of iffy, and we want to collect the science from as many of the places, the low atmosphere, on the launch pad, upper atmosphere, all of that, and make sure that we fire this off at the right time, and then finally make sure that we fire these parachutes to try and recover. Alrighty, so I've gone ahead and actually written this script ahead of time. You'll note at the top here, I've got a little note that we're going to bind the thermometer to the lights action group. Remember when we were just getting started and we wrote that script to toggle the gears on our ship? Well, what you can actually do, and this is part of what we got by upgrading the vehicle assembly building, is that we can set certain items to, say, record science whenever we trigger those actions. So we could bind this to whenever you try and toggle the gears, collect the temperature reading, but instead we're going to assign it to the lights action group, because we don't have any lights, so it's not going to actually do anything to the ship other than trigger that action. So we're going to start off by toggling the lights, or getting the thermometer reading. We're going to print that we're launching in 5 seconds. We'll lock the throttle to 0.9. I've had to tweak this number quite a bit to try and get it to a stable point so that we can get the speed that we need without flipping out. Now we're going to lock the steering to a heading. Now what this is going to do is it's basically going to make sure that we fly in a particular direction. Now this heading is based on two attributes. We've got here 90 is the first one, and what this means is we want to go east. If we were going to go north, we'd set it to 180, and this corresponds with what we see on the nav ball. Okay, so we're going to set that to 90 because we want to go east, get a little bit of a gravity turny sort of thing. Now the second value also sort of corresponds to the nav ball. If you've played before and you've done a gravity turn, you may have heard the advice that you want to eventually turn over to 45 degrees toward the horizon. 0 would be pointing exactly at the horizon, which means we're going to, if we were to try and do that right away, we would immediately go flat and then very quickly crash into the ocean. So we're going to set it to 90. This is effectively the same as saying, go up, please. So we've locked the steering to that, and that's going to mean that it's going to go ahead and try and self-correct to make sure that we always remain going in that direction. Now, an interesting thing is I tried lock steering to up, and this is supposed to be decent, correct syntax, but for whatever reason, I found that it was much more unstable. So just using this 90-90 trick seemed to work for me. So then we're going to wait 5 seconds so we have time to collect and transmit the science. We'll go ahead and print launch, and we'll stage. And then I've actually combined these two lines here. We're going to wait 1, and then we're going to toggle the lights. So in most languages, if you, for example, JavaScript or Java or any number of things, you can actually do two things. We can say, var x equals 1, x equals x plus 1, x equals 5, or whatever. We can do multiple statements as long as they have that ending line. Where more traditionally you might see them split up in something like this, you can also do that for concision. And just to try and keep this short, I've gone ahead and said, wait 1, and then we'll go ahead and toggle the lights, which means we're going to get a thermometer reading once we've taken off. So then we're going to wait until our solid fuel is less than 0.1. Now there's an interesting thing here, and that is the way that KSP represents resources using the floating point system means that it might not be 0 when your stage is empty. You might end up with 0.035 or something like that. And so if we were to try and say wait until solid fuel equals 0, then that might not fire. So we're going to just say it's less than 0.01. We're going to wait 1/10 of a second, and then we'll go ahead and drop the boosters from our solid fuel. And then we'll go ahead and stage and fire up that LV909 engine. Now, the last thing we're going to do is we're going to wait until the altitude is greater than 20,000 so we can get our upper atmosphere stuff. Actually, let's make that 30,000 just to be safe. And there we go. We'll wait until our altitude is above 70,000 so that we are in outer space and get more data. And now all that we're going to do is we're going to wait to stage our parachutes. And we're going to use, instead of altitude, we're going to use alt radar, because altitude is the altitude from sea level, which may not be what we want if we're coming down on an area that's higher than what we might like. So we're going to wait until we're 500 meters away from the surface, and then we'll go ahead and stage, and then we'll wait until we are less than 1, and then we'll wait a second to make sure that we've landed and get science from wherever we have landed. Okay, so really quickly before we take off, we need to set that action group that we have in our script. So we can go up here to action groups, and remember that you need to upgrade the vehicle assembly building for that to happen. And we can actually set these things to happen on any of these. And once we upgrade further, we can get some custom action groups where we can set up our own stuff. But we're going to go ahead and take the light action group, and let's zoom in here until we can see that thermometer, and we'll go ahead and click that, and we can see we get all of these things. We can say toggle display, log temperature, and that's what we want, is to log the temperature. So now anytime that we switch the lights, it will go ahead and try and log the temperature for us. So we'll go ahead and save that, and let's launch. Alrighty, so let's go in here, let's bring this up real quick, open the terminal, and I'm gonna go ahead and shrink this down because we're gonna have to look at this for quite some time. We're gonna go ahead and say copy orbit from 0, our archive CPU, and then we'll say run orbit, and let's see if we can manage it. I'm going to actually open up the contracts tab real quick. It does say that we are at Kerbal, so that's good. We just need to make all of these other conditions before we try and fire off that LV909 engine. So let's go ahead and run. And there we go, we get some science already. We're going to transmit that, and it's waiting, and there we go, more science. Huzzah. And you see we're going really fast, but we need to make sure that we hit that 400 so that we can fire this thing off. So as long as we don't flip out, oh, there we go. That's not good. Now, hopefully, okay, so it's able to correct a little bit. Now the question is, we've gotten these logs. The question is, do we have enough fuel to still make it to space? So the thing is that as you start to get into this lower middle atmosphere, it's very, very finicky if you try and go too fast or try and tilt too much. Now, unfortunately, our script is not set up to handle if it doesn't get above that 70 kilometers, because if we don't hit it, then it will just be waiting for us to get to that condition, which means it's not going to deploy these parachutes. So let's hop out to the map view and take a look and see how we're doing. Oh, and this is something I suppose is worth mentioning. You can see that there's this line here that shows a line from the Kerbal Space Center to our orbiter. And what this does is it actually it's showing that we have a connection using this this radio that we've got here. And so as long as we stay in here, we can still interact with the CPU. We could kill the program and write our own stuff. We do any number of things. And for some, okay, that's weird. Why was that there? That shouldn't have been there. So now it's just a question. Once we get over, I think, would we say 30? I'm not sure if I set it to 30 or 20. We'll see. Once we get over that, we should record some more science. But on the positive side, we did get this contract, and we did get some science from low orbit. So even if this is not recoverable, we've at least gotten something out of it. So, okay, so we're coming up on 30 here, and there we go. We can transmit some more science. Now, the other thing, though, is that we are using a lot of electric charge to do this, so it's going to be kind of iffy. Let's hop out to the map view and see, oh, look at that. I think we're going to get to space, guys. And we should splash down in the ocean, which is fine. It means we didn't need that alt radar. That's short for altitude radar, I'm assuming. And as soon as we get to space, we should be okay. So one of the things that we're going to want to set up, though, is that if we were to try and orbit, this line is going to, because basically we can only do things so long as we have a direct connection with Kerbal Space Center, or we can relay to other things. And there we go. We get our in-space temperature. We'll go ahead and transmit that. And, of course, that's going to eat up a lot of electric charge, but I think we should have enough that we're still able to handle the landing. Now, but the thing is that if we were to, say, go around the other side of the planet, we wouldn't be able to connect here. So if we wanted to do any more stuff with this probe, then it really needs to be able to generate its own power, because otherwise the electric charge is going to burn out before we can kind of do a full orbit. So we either have to program everything in advance, or we have to get some solar panels. So hopefully we can get some more, so we can open up the first solar panels and start to deploy some relay satellites that can handle that connection. Once we get multiple things orbiting around here, the Kerbal Space Center can transmit to, some probe over here, which can transmit to some probe over here, which can, hit something that we've got over there. And now it's just a matter of waiting for the planet to spin beneath us so we can start pummeling back. I do want to point out that both the craft files and the script files that we wrote for this episode are available on GitHub if you care to play with them yourself. There's a link in the description where you can find that. I'd also be really interested in hearing your feedback on kind of the format of this series. It's a little bit of a challenge because it's not quite a Let's Play and not quite a programming tutorial, but I'm having fun kind of trying to merge the two. And as we can see, the planet kind of spins beneath us, and unfortunately I discovered as we landed that alt radar calculates from the middle of the vessel, so we're actually not going to get that science because the program never detects that we fully landed. I think it thinks that we're still about 2 meters up the ground. We also kept the steering locked, so it is fighting valiantly against gravity to try and keep itself stable and pointed in an upward direction, despite gravity trying to pull it back from that. But nonetheless, we did manage a fully successful landing, which is great, and the lost science notwithstanding, all in all, pretty good. So anyway, that is it for me, and I will hope to see you next time. Cheers.